Kia ora. I'm Simon McKellum, and this is the introductory lecture to AI at Victoria. Now, my name's Simon McKellum. I did my PhD on the functional purpose of REM sleep in mammals, and those were neural network models of the brain. And I've been teaching AI from 1998 and game development since 2004 till currently. I was a wild man in the Lord of the Rings, so I have a New Zealand link, having been born and raised here. Did my PhD at Otago, worked in Norway for many years, and I'm now working at Te Rangawaka, Victoria University of Wellington, and also in Australia and still slightly in Norway. AI is not new. I know it's exploded, everybody's talking about it now, but it's actually been around for quite a long time. I started my PhD in 1997, way back at the far end of that graph. And if you have a look, over time, computers have got better and better at things which we thought were hard for humans to do, and we've worked out ways to do them. Very recently, in the block above here, is we've started having language models, and rather than just understanding language, we're now starting to generate language. And so let's dig into, why is generating language and understanding language so hard? Well, translation is hard. And that idea of usage and meaning, and how you use words so that you can translate them between languages or even understand what they mean. So for example, when I say the old man's glasses are filled with, what does glasses refer to? Is it spectacles? Or is it a cup that I'm holding? And if I said the old man glasses are filled with a sunset, that'd be spectacles. If I said the old man's glasses are filled with whiskey, that'd be the tumblers. If I said, so filled with a liquid means that they're things you hold in a thing. So if I said the old man glasses are filled with tears, tears are a liquid, but that's to do with the face and the eyes, and so that's probably still spectacles. But then if I said the old man's glasses are filled with liberal tears, you probably think, that might be... How do you understand the word glasses so you can translate this sentence into other languages which make the distinction between spectacles and tumblers? So that's one of those really deep challenges in translation, is you have to understand words and understand what an old man is and his relationship to spectacles to know how to translate that word. Now, how do you go from word to concept like glasses to spectacles? So we have, a tokenizer. So what we do is we take each of the words and we turn it into a number. We then take that number and turn it into a vector across multiple dimensions. Now, I know that's a little sort of hard to understand math, but what we're actually talking about here is, you can imagine that you might have an axis on the far side there that is a male to female, a man to woman axis. And so men would be on the far side left there, and women would be on the right. So king and queen have that same relationship. So there's a number associated with the amount of maleness associated with that word, right? Or femaleness in this case. And there might be another axis going this way, which is the amount of authority. So king is more authority than male. So that's on a different scale. It's on a different number that you'd associate with. And so, you could measure people by their height and their hair color and their finger length. So you could imagine a human could also have a whole bunch of numbers associated with them. And so each word can have a bunch of numbers on different scales associated with them. Now, here that could be male-female axes and authority axes, and you could have action and what kind of action it is, and a relationship between countries and their capitals, and the idea that there might be this country capital axis that relates to how you relate to another entity in the world, another word and another concept. So the idea is we take those words and we turn glasses into a number, and then we associate it with a certain amount of faceness and a certain amount of holding cuppiness, and then later we're going to have to work out which one exactly that is. How we do that is by having layers. So the transformer model, which is the one that ChatGPT got all excited about, and that's where it comes from, is that you take those vectors, right, and you combine them with the words on either side to understand the concept of those words. So when I say my family is from Matilda, that goes through multiple layers and ends up in a meaning space. Now that meaning space takes words like glasses and takes words like Matilda and family, and it understands the concept that I'm talking about. Right? So it doesn't reason with it, it just turns those words into a vector which works out their meaning by working out the words on either side and going through multiple layers. And actually Llama 2 has 32 layers of that, 32 of those layers of working out what a concept is based on the concepts on either side of it, to generate a meaning space. Then it takes that meaning space and translates it and gives an output in another language. Right? So to translate, you don't go straight from word for word, you go from the sentence to the meaning, and then from the meaning back to the sentence in another language. How this was trained is you'd start in English, you'd train from English to concept, and then back out to the English version, trying to predict what the word that is missing is. Right? In this case, it is. So there's this idea that you're trying to translate from English to English through the meaning space. What was amazing, what we found out in 2020, was that you could actually go from English to meaning space and then back to English, and then from English to meaning space and out to French, which was astounding. And so there's this idea that actually humans talk about similar meanings. Now, that meaning space is often called the latent space. So you'll see that if you read any of the literature on this, that latent space is how we turn those concepts into vectors that relate to each other. Now, what this is showing you is that you can go from a spectrogram. So a spectrogram is a time and frequency sound wave. So this is a sound wave, a sound that someone would make. We train it to go from the original spectrogram to latent space and then back out to that spectrogram, right? So we train it to compress that information and put it in what sound you're trying to make in a kind of meaning way. And what we can do is as we move through and find neighbors of words, we can create sounds that are similar. So you can imagine if you were going from the word tree to the word bush, right? Concepts are quite similar. But if you just tried to do it letter by letter, tree to bush, would you replace the T first and get a bree, and then U and get brew, right? That goes through random connections if you were looking at the letters of the word. But once you move it in concept space, right, into this latent space, when you change the height of a tree, you might move to shrub. And then if you changed it even more, you might move down to bush, right? So there might be a height axis, which would change the concept you're talking about, and then that would change the word that is being output, right? So what these language models are doing is they're not trying to just guess the next word. They're changing your sentences, your context, into a concept, and then using that concept to generate a sentence. Okay, so that's why these things are so powerful, is that they're not just copying from the internet, they're not a search, they are translating from words into latent space, into concepts, and then back out to words. Once you understand that that's what's happening on the inside of, well, the core part of language models, you can then start thinking, well, how can I use that to help learn things? And also, it's not going to be particularly good at reasoning because all it's doing is compressing the concept. It's not comparing sizes of things or doing math. Now, later models, and we'll talk about those later in this primer, they have actually been adding other systems. But the core language models were just about conceptual interaction. You can actually see inside that latent space. So here that was a latent space moving through sound. We could have a latent space moving tree down to bush. Here we had a latent space which was looking at when you train the language models on all of these landmarks, one of the axes it builds is a world longitude latitude, right? It builds the axis of where it is in space so that it can build connections between landmarks. When you treat it on historical items, you can actually see that there's a relationship between the dates and the vector in that space. So it's built in a concept of when something occurred. Right? Now, if you just refer to it like man, that might have 0 time axis value because a man could have happened at any time and a woman could have happened at any time. So there's 0 on that axis. But if you talk an old man, you might have a time component associated with that concept. Okay, so this is what we can see here is that it's learning and it has learnt interesting axes that we can understand. Now, we started off with text, and that came to latent space, and then latent space went back out to words. Now, the reason why I go text to words is because words are like text as a similar concept, but it's just slightly different. And that's what you sometimes get, is you go through text and you get out a slightly different latent space. Out of the latent space, you get a slightly different concept. We can go from images to that latent space, and we can go from text to the latent space and go from latent space to either text or images. In fact, now when Google's been adding things where you can go from video to latent space, there are emotions to latent space, there is fMRI and brain scans to latent space, and when you come out, there are words, images, audio, video generation. Morpheus is dream controlling technology, which is really weird. And Neuralink, this one here, is the terrifying Elon Musk brain electrodes controlling your brain, where you can go from latent space, where he can read your brain, and also write concepts into your neurons, right? So that you can control mice and also get information directly from the internet straight into your brain. That's very scary. That's not what we're going to have to deal with today, but we're certainly going to look at some of these text and image inputs, and certainly text, image, and video outputs. Now, Google has recently released a Gemini model. In terms of its performance, it is similar to ChatGPT-4, beats it in some metrics. It uses a single latent space. As you see here, it's got multi-modes of inputs all going to that central latent space and then back out to different types of outputs. In the MMLU, which is a multi-choice quiz, that is a generic understanding of lots of different fields, tens of thousands of questions, it gets 90%, which means it can answer most knowledge-based questions across most subject areas. It can also code at over 85% of the LEET code tests. So it's not just good at language, it's also good at programming, and it's starting to be able to understand images and video. One of the things that is coming is that once you can understand images and you can understand language, you can then start also working with your outputs being actions, right? In this case, robotic actions. So this is RT2. This is Google's one of Google's robots, and you can ask it questions in English, and it will look at the scene, understand the content of the scene, and be able to manipulate that world. And so these words are no longer just, words in a book or words in the internet. They are now connected to physical objects in the world. So when I say pick up the extinct object, it works out from everything on that table which one of those is extinct, and then physically goes and picks it up, and it can move it beside things and put it on top of things. It understands physical relationships as well as the names of objects. This was their GIF, which is a bit terrifying as it seems to be consuming all of the internet faster and faster and faster, then consuming tiny robots to become friendly RT2. They thought that was a fun GIF. I kind of feel that's a bit of a terrifying GIF because it shows the consumption of all of our newspapers and code and games and videos and actions and other robots into a new tool. So that's the sorts of things that are coming. So in this primer, I thought I'd take you through some of these ideas, and then we're going to look in later videos on how you can use language models. just to continue the theme of what's coming and the amazing, interesting research that's out there. Meta was doing work with fMRI. How they did this was they would show images to a human, and they'd have a brain model, and you'd do a retrieval and regression and then go through a generation to look at, if you view this image, what image do I predict that you're viewing? And so what it's trying to do is saying, well, if I know what image you're looking at, and then I can see your brain activity, how much of that image could I regenerate it from your brain activity? Right? So how's the up and down? Like I was doing with words, we're going to the latent space and then back out to the words. This is image to fMRI scan and then back out to words. Once I've worked how I take the fMRI scan, move it to concept, and then back out to image to concept and out to image, and brain scan to concept and back out to brain scan, I then can start training it on how to translate the brain scan into the image you're seeing. And what that does is it gives you this sort of video where in real time, actually it's slowed down, I show the user an image, and then from their brain activity, I can decode and generate images. Right? So this is a crazy brain scanny thing, but that is the power of going from an image to a latent space and then a latent space out. This goes from neural activity to latent space and latent space out to image. Right? So this is that kind of power of conceptual understanding. You can see there the cheese is similar to the cheese. Now, AI is kind of snuck in without you watching. Right? If you've got an iPhone, for example, this image comes from a woman who was taking her, trying on a wedding dress, and as she was taking the photo, or as her friend was taking the photo, she dropped one arm and then the other. Because if you look closely at the arms in this image, you see in the foreground, she has half an arm up. In the image closest to us, she has two arms together. And on the far side, she has both arms down. This is actually an example of Apple using high dynamic range, because in the mirror closest to us, it's very, very bright. So it would have used a very short shutter speed. In the one closest to us, it's a medium shutter speed. And on the other side, it's a very dark image because it's the other mirror. And so that would take the longest exposure. And so what it's doing is it's actually it's combined those areas into a single image, because it knows that you want to be able to see all parts of the image. And so rather than showing you some bits dark or some bits overexposed, what it does is it combines images from 3 different time steps. It does the same when you're looking for people with eyes open. Right? They go, well, we know you wanted everybody in the image to have their eyes open. And so when you take the photo, it goes, well, I've got these 10 photos I actually took, and so long as I combine the eyes from the different photos, I can get one image of everyone smiling with their eyes open, even if that never happened. And so AI is starting to be part of a lot of what we do on our devices and things that we do with computers. You will have noticed potentially Google has started in Google Docs adding the Help Me Write, and Copilot is coming to Microsoft. These tools are being embedded into just the standard computer tools we use. That does lead us to some rather challenging ethical questions and ownership questions of who's made what. So for example, here we have an image that my daughter Brenna drew when on her phone with her finger. She likes drawing cats. And then I took that and put it through Stable Diffusion, and we had this slightly smoothed out cat, right? Which is kind of, it's still very much a cartoon cat. It still has most of the coloration she has, but it's added a bit smoother around the eyes, and it's smoothed out the rough around the chin, around the cheek rather. And so it's kind of, where does her ownership end of that image? She manually made the first one. The second one is using the algorithm AI just slightly to tune it up. But you could get some of that just by using Photoshop a little bit better than she did. The next one I asked it for was a 3D version, a 3D cartoon version. And now this is getting quite a lot further away from her original drawing, but you can still see the DNA. You can still see the posing that she had. This is her composition, but not her drawing. So if this was a photograph, you'd say, well, that's clearly a photograph that she took. And she posed the cat and picked the right color cat and had a cat with weird large eyes. And so this is something that it's her intention to create that image. And that was her prototype for it. So it's very hard to know, and we still don't have clear understanding of exactly where ownership ends. And that's hard for copyright and intellectual property. And those discussions are going to come up during your university career. And you will have to have these discussions in many of the courses that you're taking. Now, of course, you can go further and you can go, hey, make me even weirder characters. And it makes it a bit weirder and doesn't stick as tight. And then you can say, make it photorealistic. And a Siamese cat's looking at the camera with the image, the eyes. So this is the photorealistic versions. Now, those are even further away, but you can still see the colors, right? You can still see the color of the cat and the fact it's looking at the camera, and the eyes are a bit big in each of these cats. So there's still some of what she originally posed in these images. Now, here's a bunch of models. We're going to go over some of how these work and how to use them in the rest of this course, but I'd just say, look, lots and lots of models. This isn't one company that's taking over the world. This is lots and lots of different companies and products and tools that are all able to be used to help you learn or solve problems or take away some of the drudgery jobs. Now, what we have to be careful of is that when you use these tools, you don't replace your effort in learning, because learning requires effort. And if you replace all of the effort, unfortunately, you're not going to learn. So what we're keen on doing is trying to help you use AI and use these AIs to help you learn faster and to supplement you when there's a task that's getting in the way that we're not trying to assess you on, right? This isn't a core to what we're doing. It's just something you'd have to do. And what we want to do is actually test you on the course you're doing, on your chemistry, not on your writing. So what we're looking at is how do we help you learn the core of what you need in each of your courses and use AI to help you learn that, and also to get rid of some of the tasks that just slow you down. That will lead us later in this primer to discussions around safety, and lots of people talking about safety. Elon Musk has even predicted the end of all jobs, which is a bit terrifying, but he's a bit crazy, so maybe that's going to happen or not. There are agreements from large companies to work on safety. The US has written executive orders on AI and safety. The EU, European Union, has got policies coming through around how we regulate AI and how we ensure that we can detect AI. Meta is asking people to disclose the use of AI in any political activities. And here in New Zealand, the OPM CSA, which is the Office of the Prime Minister's Chief Science Advisor, is working on AI in education, because AI is a critical topic that the Prime Minister needs to know about, right? And that was happening before, from the middle of last year. What we're also going to see, apart from all those safety discussions, are discussions around large companies of AIs. So it's not just one AI, it's actually a group of AI that you're going to be interacting with. And that makes it harder and harder to make a simple distinction of, oh, I asked the AI this and it said this to me. It's kind of, well, I asked the AI and it went today and did a whole bunch of work and worked out a whole bunch of stuff, and the team came back to me with an answer. Or, as we might see in some of the later stuff we do in this primer course, you're going to be part of a team with AIs. So the AI will come with ideas, and you'll work with those ideas and suggest new ideas back to the AI, and then it will help you with reviewing your ideas, looking at your ideas from a different perspective. So it's not this is what the AI said. It's there's a team of AIs with different perspectives. What does my team think about this concept? There is a change coming in society. If you look at AI as a 5 times multiplier, all right, so if it makes you 5 times faster at part of your job, then you only need the 20% most innovative companies to take over an entire industry, particularly if it's finite demand. If it's infinite demand, then, no matter how much more productive you become, there's still demand for that. And certainly at the moment in healthcare and education, we don't have enough teachers and nurses. So if we can make them more productive, that's fine. We need more of them. So there's kind of an almost infinite demand that more tutoring and more one-on-one support improves education. Whereas if you're auditing jobs or there's a finite demand for the number of activities that need to be done, then AI is going to change those workplaces. We do not know yet which jobs and which workplaces are going to be most affected. But certainly, if you are going to try and work with AI, then you are more likely to be able to ride the wave of AI rather than get run over by other people using AI. Unfortunately, that leads us into a state of what I've been calling a cognitive nomad. It's this constant change. You have all gone through COVID and suffered a massive amount of change suddenly, and then changing back and forth and changing levels. And so change is something that you've had to deal with. Unfortunately, AI is going to keep making changes. It's going to keep updating and changing what's possible and what's not possible. So you can't just think of it as, what I'm going to do is I will incorporate AI. Once I've incorporated AI, I can then keep doing what I was always doing. Kind of, no. By the time you've worked out how to do that new thing, it's going to move on. There's going to be new things. So we have to keep this mindset of, I need to be agile, I need to be flexible, I need to think about what my values are and what I care about, and I need to understand deeply what my goals are rather than just mechanically do something that currently is valuable. We don't want you to be the worst player on the team. Now, when games like FIFA had AI players, there was a stage there where I was pretty bad at FIFA games. It was better for me to grab the weakest player on the field and run to the corner and let the AI go away and score because I was the worst player on the field. However, if you do that, you never get better at the game. So what we want you to do is say, okay, even if I think the AI could do a better job than me, for some of these tasks, I'm going to have to do it because I want to become a better player. I want to get better at this task. I need to get better at the task because at the end of the day, I'm going to be assessed to get a job. So I can't just say, hey, we'll hire the AI, don't hire me. So that's partly why we want to teach you to use AI and make sure that you can use AI in a way that helps you. There are tutors out there, so there are AI tutors. So Khan Academy has one. You can ask the AI to give you options and custom instructions. And we're going to go through some of these ways in which you can use that AI to improve your learning, role-playing conversations, analyzing images and videos, building perspectives. We're going to go through that in different videos in this session, and you'll see that there's an introductory 5 sections. I'm going to record videos over this trimester and work with students and work out what you actually want to talk about and what questions you have. So there are tools out there. We're going to help show you some of those tools, and hopefully you can use those to improve your learning. So what's coming? Lots of agents. Reasoning is coming. Everything mediated in computer is going to be false, which is going to be really hard to work out. And a bunch of staff are already trying to work out how we deal with that with assessment. Memory is coming for AIs, so they will remember you and remember your interactions. That's going to be interesting. Agency, where AIs are in charge and doing their own actions. And finally, before I say evening for this recording, we need to work together as a community to reshape what it means to contribute to a project. Because at the moment, we value things by the cognitive effort you put in. With AIs doing some of that work, we have to find new ways as a group, including you as students, of valuing contributions and understanding the role that you as a participant, as a student, as a professional will have working with AIs. This is not a journey that we already know the answers to. You are going to have to help us as lecturers work that out. And so hopefully this primer will help with some of that, help improve your use of AI so it's more strategic. And you'll give us feedback and we'll change the content as we teach. And hopefully this will be a fun wee primer. There are other courses that will teach you far more about AI, and we will have pointed those in the Nuku pages. But with that, hopefully you'll be interested and stay around, go and chat on a Discord page and follow along, give us feedback on what you want to know about AI. Great. Have a good day.